Okay, let's kick things off with a quick thought experiment. Imagine I just placed 5 invisible pebbles right here on a table in front of you. What did your brain just do? Well, without even trying, it counted them. That instinct, that deep-seated drive to know exactly how many, is literally one of the oldest things about us as a human species. And our very first physical record of this? It actually goes back roughly 43,000 years to this fascinating artifact known as the Lubumbo bone.
Picture this. Someone in prehistoric Africa took a baboon fibula and carefully carved 29 distinct notches into it. They were tracking something, maybe a lunar cycle. And for tens of thousands of years, this was the absolute bleeding edge of human mathematics, the tally mark. 1 mark per object. But as brilliant as it was to finally have a permanent record, tallies had a pretty fatal flaw. You just can't easily add, subtract, multiply, or divide with them. So as human civilization started growing, building these sprawling cities and trading across oceans, that limitation became a massive, massive problem.
The story of numbers, from ancient bones to binary. Welcome to This Explainer. I am absolutely thrilled to explore this topic with you today, because we are looking at what is arguably the ultimate human invention. We didn't just stumble upon numbers, we painstakingly built them, piece by piece across millennia, to survive, to trade, and eventually to decode the deepest mysteries of the universe itself.
Part 1. The instinct to count. Let's dive into some of those early roadblocks.
So, early societies hit a massive wall when they tried to use basic counting for incredibly complex things, like calculating city taxes or engineering massive structures. I mean, just try multiplying the Roman numeral XVI by XIII on a piece of paper. It is practically impossible. The Roman system was fantastic if you just wanted to carve a date into a stone monument, but it was an absolute nightmare for daily calculation. Because their number system made arithmetic so incredibly clunky, it literally limited the Roman Empire's capabilities in science and engineering.
And hey, Rome definitely wasn't alone in the struggle. When you look at how different civilizations operated, from the Egyptians with their hieroglyphics to the ancient Greeks, they all built entirely different additive systems to solve their specific cultural problems. But they all shared one massive calculation bottleneck. They required repeating symbols over and over, and absolutely none of them had an efficient way to handle large-scale mathematics. The world desperately needed a breakthrough.
Which brings us to Part 2, the place value revolution. This was the first great mathematical leap that completely fixed this calculation nightmare. Think about the number 111. It seems so obvious to us now, right? But think about the absolute brilliance of what's actually happening conceptually. The exact same symbol, a 1, means 100, a 10, or just a single unit, purely based on where it sits. You don't need a brand new special symbol for larger quantities anymore. You just shift the position. This concept of place value was an absolute game changer.
And early adopters of this concept quickly put it to work. About 4,000 years ago, the Babylonians developed a base 60 positional system. With it, they were suddenly solving quadratic equations and predicting astronomical eclipses literally thousands of years before Europe caught up. And here's a fun fact. We actually still use their system today every single time we look at a 60-minute hour or a 360-degree circle. But despite their genius, the Babylonians missed one critical piece, and it left a gaping hole in their mathematics.
Part 3, the power of zero, or how to represent nothing.
So positional systems were incredible, sure, but they eventually hit a wall. What happens when a position is just empty? Seriously, think about this for a second. How do you write 302 if you don't have a zero? If you just leave a blank space between the 3 and the 2, is it 302, or is it 32 and you just have messy handwriting? The Babylonians tried using a little placeholder marker, but it wasn't a real number. You couldn't add or multiply with a blank space. Positional systems were fatally ambiguous without a solid way to mathematically represent nothing. Well, the true breakthrough happened next. Between the 5th and 7th century CE, mathematicians in India made one of the most profound conceptual leaps in all of human history. They decided that nothing deserved to be a real number in its own right. Zero wasn't just a typographical blank space anymore, it was given its very own symbol and its own unique mathematical properties. 0 plus any number equals that number. 0 times any number is 0. This single insight unlocked the modern Hindu-Arabic numeral system, which is, without a doubt, the most efficient and powerful number system humanity has ever devised.
Part 4. Algebra and Algorithms. The Islamic Golden Age. Now, this invention of zero
allowed for an entirely new mathematical infrastructure. We often get this skewed version of history where math basically jumps straight from ancient Greece to European scientists. But mathematics is actually a deeply global human collaboration, from Babylonian clay tablets to the Maya independently inventing zero over in the Americas, to the Indian numeral system. Humanity was essentially passing the baton of knowledge across continents and centuries. And the next great handoff, that happened in Baghdad.
Working in Baghdad's House of Wisdom around 820 CE was a brilliant Persian mathematician named Muhammad ibn Musa Al-Khwarizmi. He wrote a book that formally introduced the Hindu-Arabic numeral system to the wider world. And here is a totally mind-blowing fact. When his book was later translated into Latin, his name was Latinized into Al-Khwarizmi. That's right. Every single time you complain about the algorithm on your social media feed, you are actually speaking a 9th century mathematician's name.
But Al-Khwarizmi didn't stop there. He wrote a second massively influential book featuring a concept called algebra, which beautifully translates to the reunion of broken parts. You and I know it as algebra. This absolutely revolutionized mathematics because for the first time ever, it allowed us to systematically solve for unknown variables instead of just doing static, straightforward arithmetic. It was a completely new way of thinking about the relationships between quantities.
So let's trace how this incredible system finally took over the globe. Step 1, Hindu-Arabic numerals are perfected in India. Step 2, they get supercharged by Al-Khwarizmi's algebra. Step 3, this system reaches Europe in 1202 CE. That's when a young Italian mathematician named Fibonacci published a book showing European merchants just how much easier it was to calculate with 0 through 9 than with those clunky Roman numerals. This sudden surge in efficiency essentially killed off the Roman numeral system for commerce and laid the precise calculable foundation required for the scientific revolution. I mean, Galileo and Newton simply couldn't have done their groundbreaking work without the tools brought over by Fibonacci.
Which brings us to the craziest part of all this. Part 5. The language of nature. What's truly profound to me is that these tools invented purely for counting sheep, collecting taxes, and managing human trade, somehow turned out to be the hidden code of the universe itself. Take Fibonacci, for example. In his book, he included this whimsical, completely abstract puzzle about how fast a pair of imaginary rabbits might reproduce. The solution was a sequence: 1, 1, 2, 3, 5, 8, 13, and so on. But here's where it gets astonishing. When botanists look at the natural world, they find exactly this sequence everywhere. Sunflower spirals almost always count out to 34 and 55. Pine cones and pineapples segment into 8 and 13. The chambers of a nautilus shell perfectly approach the golden ratio. An abstract, made-up puzzle perfectly predicts the exact physical spirals of plants that evolved millions of years before humans even existed to count them. No way, right?
This uncanny connection has left the greatest minds in history in absolute awe. As Galileo beautifully put it, the book of nature is written in the language of mathematics, and it goes far beyond sunflowers. Abstract math keeps predicting physical reality long before we even observe it with our own instruments. In the 1860s, Maxwell's equations predicted radio waves before we even knew they existed. In 1928, Dirac's equations required the existence of antimatter purely to make his math work out consistently. And then 4 years later, we physically discovered antimatter.
This brings us to what physicist Eugene Wigner famously called the unreasonable effectiveness of mathematics in the natural sciences in a 1960 essay. This is known as Wigner's puzzle. Why on earth does our human aesthetic logic, rules we literally just made up in our heads to see what would happen, perfectly match the deepest invisible structures of physical reality?
Well, there are two major philosophical answers that attempt to solve Wigner's puzzle. On one side, we have mathematical Platonism. This is the idea that mathematics is discovered, not invented. The truths are already out there in the fabric of the universe, and we are just mapping them out. On the other side, we have the human construction theory. This argues that the universe only appears mathematical to us because math is the cognitive tool we built to look at it. It's kind of like wearing blue-tinted glasses and then marveling at the fact that the whole world looks blue. Both are incredibly compelling arguments that have occupied brilliant minds for centuries. And truthfully, neither provides a totally perfect answer.
But regardless of whether we discovered it or invented it, the power of math is undeniable. Just think about the screen you're using to watch this explainer right now. Every single image, every sound, every pixel, every word, it's all running on a binary system of just 2 digits, 0 and 1. The vast complexity of our entire digital age is a direct descendant of that very first 0, boldly conceptualized by mathematicians in ancient India.
From a single notch on a prehistoric bone to the code powering our global internet, we've built our entire world on these symbols.
Which leaves us right back where we started, looking at the symbols we use to make sense of the chaos. So what do you think? Is mathematics discovered or is it invented? Are we reading the universe's original source code, or are we just writing our own human story onto the stars? It is a fascinating mystery that remains completely unsolved, and I invite you to keep pondering it every time you count, measure, or solve a problem. Thank you so much for joining me on this explainer, and keep exploring.